Question number 7, we need to find the coordinates of the points on this curve at which dy dx is equal to 0. Now this equation is an implicit equation. So to find the derivative, we need to make use of implicit differentiation, where we differentiate both sides of this equation with respect to x. So the derivative of y cubed with respect to x will be 3y squared times dy dx plus, now to find the derivative of 3xy squared, I'm going to factor out 3, and we need to make use of the product rule to find the derivative. So let's do some side work. I will let u equal x and v equal y squared. So u dash, the derivative of u with respect to x, will equal 1, and similarly the derivative of y with respect to x will be 2y dy dx. Now the product rule is u v dash plus v u dash. So this will be u v dash, so x times 2y dy dx, so 2xy dy dx plus v u dash, so v times y squared times 1, which is just y squared, plus y squared, minus, now the derivative of x cubed with respect to x will be just 3x squared, and the derivative of 27 will equal 0 because this is a constant. Now from here we can expand this bracket. This will be 3y squared dy dx plus 6xy dy dx plus 3y squared minus 3x squared is equal to 0. Now from here I can factorize dy dx from these two expressions. So this will be dy dx inside the bracket 3y squared plus 6xy. This will equal, and I can move these two expressions to the right hand side. So this will be 3x squared minus 3y squared. From here I can solve for dy dx. So dy dx will equal 3x squared minus 3y squared divided by 3y squared plus 6xy. Now I can simplify this expression a bit. I can factor out 3 from the numerator and the denominator. So this will be dy dx. This expression will be simplified to x squared minus y squared over y squared plus 2xy. So now that we have an expression for dy dx, we can set this equal to 0 because we need to find the coordinates at which dy dx is equal to 0. So x squared minus y squared over y squared plus 2xy, this is equal to 0. From here the denominator will multiply with 0 and this will become 0, so we'll be left with x squared minus y squared is equal to 0. From where I can move y squared to the right hand side, and this will be y squared is equal to x squared. Now I can take the square root of both sides, and this will give us y is equal to plus or minus x. Now you could also do x is equal to plus or minus y, it won't make a difference. So now we have two relations that y can equal positive x or negative x. So we can use this relationship and substitute this back into this curve to find the coordinates. So if I'll make two columns, so let's say that y is equal to x. So I can substitute substitute x for y in the curve. So this will be x cubed plus 3x cubed minus x cubed. This is equal to 27. From here the positive x cubed and negative x cubed cancel. So this is 3x cubed is equal to 27. From here I can divide 3 with 27. So this is x cubed is equal to 9. So if I take the cube root of both sides, we find that x is equal to the third root of 9. So we have found the x coordinate, and since we know that y is equal to x, we found the first coordinate as the, let me erase this, red pen, as the third root of 9 comma the third root of 9, because y is equal to x in this relation. So we have found the first coordinate, and now I can let y equal negative x in the original curve equation. So this will be negative x cubed plus 3x negative x squared minus x cubed, and this is equal to 27. So negative x to the power of 3 is negative x cubed plus 3x cubed, negative x squared is positive x squared, so 3x cubed minus x cubed, and this is equal to 27. From here, negative x cubed minus x cubed will become negative 2x cubed. So 3x cubed minus 2x cubed will be, I'll just write this down. So 3x cubed minus 2x cubed is equal to 27. So x cubed is equal to 27. From where I can take the cube root of both sides, and we find that x is equal to 3. Now since y is equal to negative x, if x is equal to 3, y will equal negative 3. So we have found the second coordinate, that the x coordinate is 3 and the y coordinate is negative 3. So these are the two coordinates at which dy dx is equal to 0, and this is the answer to question number 7.